Hello and welcome to today's video. My name is Reinhard and today I want to give an update on the news in the WearMeasurementModule 1.5. The WearMeasurementModule is our software that is used to evaluate the wear of cutting edges as they're used in the machining process. So at different stages in the machining process, you can take out your cutting edge, measure it, and then you can see with our software how much wear has been produced during the machining process. Here on the screen, you can see how the wear measurement module looks like. In contrast to the wear measurement module 1.4, where only the wear types flank wear and notch wear have been available, the new wear measurement module 1.5 has a new main feature that it can also evaluate plastic deformation. Here on this slide, you can see how plastic deformation looks like. So you can see that during plastic deformation, when you have the depression type, the cutting edge is moved downwards and outwards of the original position. If you have plastic deformation of type impression, then the cutting edge is moved to the right and to the up. For each of both wear types, you can evaluate a series of different new measurement parameters. Let's look at the wear measurement module software itself. When you click here on the settings of the reference type, you can choose your type of wear that we want to measure. You can choose either flank wear, that was already available in version 1.4, and then you can optionally activate the calculation of notch wear, or you can choose to calculate the new plastic deformation type. For this type, you have three options. Either you select deformation depression, plastic deformation impression, or if you do not know what type of wear you have, you can also choose unknown. Another new feature in the reference type is that you can also select the number of calculated profiles. This is very similar to the way how the number of cross sections is used in the EdgeMaster module. The calculation of the plastic deformation starts by loading a dataset, then by clicking OK, and after some time you can see the result as shown here. On the left, you can see the 3D view of one of our datasets with the orange marks that show how much plastic deformation is at each cutting plane position. And on the right, you can see a profile view that shows the profile of the original orange and the worn cutting edge blue at the current cross section. Here, for this example, I've chosen also the unknown plastic deformation type, so you can see parameters of depression and impression type. Here on the right, you can see all evaluated parameters. There is one section that shows the parameters at the current cross section. And there's a series of parameters that show the maximum and the mean of the different types along the whole cutting edge. The maximum depression depth and impression depth are shown in dark orange and in red. Another new feature in the software is that we have speeded up the calculation when the cutting plane slider is changed. So for example, if you now change the cutting plane slider, you can see that the profile view on the right is changed and updated immediately. And as well, also, the parameters are very fast updated. So you can get a much easier and faster impression of the wear on your cutting edge. There are also other features. One is that you are now able also to deactivate the cutting plane. This can be either good for screenshots on the 3D view or also in the animation video. For example, here I've switched to the animation view tab, and then I can show how the plastic deformation evolves over time. Another new feature is that you can now not only show the red and green manual cursors in the 2D profile view, but you can also activate them in the 3D view. So you get much better visual impression on how the profile view correlates to your 3D view. The last feature I want to show you is a new parameter that we've added for the flankware calculation. Here in this example, I've chosen the flankware type and loaded a dataset series with flankware. Here on the right, you can see different flankware parameters. The old value VB, which is the flankware at the current cutting plane position, and the parameter VBmax that was already available in 1.4, which is the maximum flankware along the whole cutting edge. In order to get a more robust VBmax value, we've added the parameter VBmaxQ, which is the mean value of the 10% largest flankware values. So this gives you a more robust maximum value in the case that the flankware is not very evenly distributed. Brings me to the end of my presentation. Thank you for your attention and goodbye.